Welcome everyone to CommTech 2020. I'll be your host, Stephen Harris, with the SCTE ISBE. And many of you know me, and if you don't, it's a pleasure to meet you, and hello, my friends in Canada. My capacity at SCTE ISBE is to drive business results through learning and development programs, as well as certification, professional certification that is. We are in the business of moving key performance indicators that drive these business results, as well as improve the skills, knowledge, and abilities of our industry. My capacity has allowed me to remain ahead of the technology curve, to act as a presenter, a facilitator, an instructor, and a subject matter expert. I would also like to mention, before I get started, the SCTE chapter in Ontario. That's scte-ontario.com. It's on the screen. Please visit their website. They have a lot of great resources. They have an excellent board of directors, and they always have nice events that you can attend. So today we are going to discuss operational practices for home Wi-Fi deployment. So let's get started. Now, you have probably received the agenda, but we're going to look at the growth of Wi-Fi. And many of us know that it's growing by leaps and bounds, and it's one of the major pain points for operators, as well as a awesome growth area for our operators. We'll talk about some of the residential networks at 18 plus devices now, how people want to stream more HD and 4K, how the IoT lifestyle is kind of making its way. If you see on the left-hand side here, this is my IoT lifestyle. I got 14 connections going on inside my access point, and that's kind of low today. It's usually about 26. All this is very important to drive capacity, reliability, low latency, as well as security and bandwidth in the network, called 10G. You might have heard of it. And all of this is important to the quality of experience for our subscribers. So there's no longer a difference between wired connections and Wi-Fi connections. It doesn't matter if you're delivering fiber to the home or DOCSIS 3.1 or even DOCSIS 4.0 with DAA. At the end of the day, customers are connecting via Wi-Fi. It's important that we get the Wi-Fi correct the first time. We don't want to have to go back. We don't want to be on the phone with them. We want to get it right. And we want to have an excellent quality of experience with our customers. We want to overcome the challenges. And some of these challenges are quite simple. And we want to do this correct the first time and deliver the best experience. So we're going to go through the current state of Wi-Fi. We'll look through some of the standards. We'll also understand the Wi-Fi channels and how RF operates, because understanding RF when it comes to coax is different than understanding RF when it goes over the air, especially when we talk about free space path loss, and we'll talk about that. We also want to see some of the newer standards coming. Wi-Fi 6 is already here, and we'll see where that is. And there's already been an announcement at the Consumer Electronics Show this year about Wi-Fi 6E, and we'll talk about that and what does that mean for our industry. And then we'll talk about some of the troubleshooting areas. I know there's been some problems with RF and understanding how mesh operates a little bit, maybe even some band steering issues, so we'll talk about that too. And we're also going to talk about how all this relates to SCTE 255. If you haven't downloaded it yet, it's free from scte.org. It's our standard for optimizing performance for Wi-Fi networks. So please download that and take a look at it. Let's first start off with the Wi-Fi situation. What are the activities? What are the activities for Wi-Fi? And I always like to open it up with something funny. What do you guys think here? Day 3 on Mars, still no sign of life. But hey, we have free Wi-Fi. What do you think? Oh, wow, you guys liked it. All right, that's just to kind of warm us up. But let's take a look at what's going on, what's trending. You know, stream to TV is growing in all areas, as you can see on this chart. Now, the key is across the bottom. You can see traditional television, VOD, DVR, DVDs. Anybody watch those? We do get a red box here and there with my family. But most of it's streaming. And that is growing. You can see the sector is growing. Stream to computer, stream to handheld. This is the reason we need to have reliable Wi-Fi. More and more people are using the Wi-Fi connection to stream. And that's not just data and voice over wireless local area networks. So it's also video. So what's going on in the industry? You can see here global Wi-Fi analytics, US dollars 39 billion by 2026. This is the analytics that we're going to analyze off our Wi-Fi networks. That has a CAGR of 31%, over 31%. So huge dollars here. Smart city with Wi-Fi models are already being used in cities around the world. 82% of Canadians live in urban areas. So this will be really important about smart cities, leveraging Wi-Fi, Wi-Fi hotspots, IoT, and really making it much more efficient to operate within these urban areas. 94% have home internet in Canada. And there's a little tiny document that you may see here that's free, and I encourage you to read it. Canadian Internet Uses Survey. Operators are increasing deployments of Wi-Fi across physical venues. Canadians, or Canada's largest network in the Western Canada, Shaw has Go Wi-Fi. Rogers is growing Ignite Wi-Fi in Eastern Canada, as well as Access with their Smart Wi-Fi. So pretty much, I didn't mention every operator, but you can see there's a good mix of operators that are doing things with Wi-Fi, even managed Wi-Fi. And that's expected to grow quite well in 2021. During COVID, and we'll just fix that, was mobile average time on Wi-Fi for Canadians was over 75%. So even more usage of Wi-Fi. Now about IoT. IoT also comes with the whole Wi-Fi, home networking, Resi networking, also SOHO, which we call small office, home office, as well as smart city. Two areas in particular, you have utilities growing, and these are billions of base units, 1.37 billion base units for utilities, and of course physical security. But don't discount the other areas. As our SET Explorer program, under standards, our standards program is exploring autonomous vehicles, also telehealth, telemedicine, which you can see there, healthcare providers. So there's a lot of growth areas and growth segments, and it's going to be important to have Wi-Fi. So how many total IoT devices do you have connected in your home? Do you have any IoT hubs? Well, your answer should be, and may be, more than 12, right? So do you have any of these devices? Do you have any light bulbs? I have colored light bulbs that you can change the living room to blue, or you can change the front porch to orange for Halloween or something like that, or green for Christmas. And perhaps you have talking devices. I think we're up to 3 or 4, maybe even 5 talking devices in different rooms. It's a cool feature. You can do announcement and make announcements through the house now with these devices. I have Wi-Fi smoke detectors, carbon monoxide detectors, thermostats. So a lot of connectivity over Wi-Fi. Obviously, we could add in our Alexa televisions, if you have one of those as well. And here I'm going to show you a little short snippet. It's about 4 minutes, but I'm going to show you a little bit less. But 26 billion connected devices, they're saying now in this year. Cisco says 50 billion. Gartner says the 26, and Morgan Stanley says 75 billion. But take a look at this scenario.
Come on, Cookie.
So you might have saw this video.
I don't know how you're supposed to feel at 86, but I don't think I feel like I'm 86.
Surprise!
People make my world go round. I fear isolation and being cut off. If I am alone somewhere and I had no one to talk to, no one to share anything with, I bet you I would just dry up and blow away. I call this my smart house. We've got sensors in all the rooms. I swallow them. I wear them. Doc knows what's going on with me. I don't have to go to the clinic anymore. I call him up. He's not back in the horse and buggy days.
Looks like you had a pretty active week, huh?
I'm feeling it too.
Hey guys, how do you like your ride?
Knowing I got eyes on me gives me the confidence to keep me being who I am. Doing what I want to do frees me up. Takes the worry away. I don't have to worry about Paige, my dog.
So that should give you a little bit about motivation for Wi-Fi. And everything I showed you so far, there's a lot of growth, right? So besides the growth factor, there are some new standards here. I have AC, which is Wi-Fi 5, and AX, which is Wi-Fi 6. Through project and platform 10G, which SETE, Cable Labs, and NCTA are a part of, we're driving all of these components. More reliability, more bandwidth, more security, reduced latency, we call it agility, service velocity, and higher compute, even edge compute. So really, Wi-Fi with these two standards shown here are moving in the direction to evolve to address all these things that I have on the screen. Now, let's highlight some of the standards. Let's first start off with Wi-Fi 5 is 802.11 watts. Anybody know? Think to yourself. How about Wi-Fi 6? So Wi-Fi 5 and 6 were easy names for consumers to learn about Wi-Fi. Because knowing all the IEEE working groups is a little much. But hopefully you came up with AC and AX that I mentioned, right? And that's just some of the newer ones, right? Here is the evolution of IEEE Wi-Fi. And you could start all the way back here with B. And I don't even have A on my list here. But A was out there as well in the beginning. And then moving all the way over to 2020. So right where we are now, we're still deploying 2015 technology, which is Wi-Fi 5. So you can see we've been doing this for a couple years. It's AC, 802.11 AC. It does a 1 gig service, and we'll talk a little bit about that. And then there's the next gen. There's Wi-Fi 6, and we'll take a look at who's doing Wi-Fi 6 and what are some of the advantages. You probably heard of MIMO, but multi-user MIMO with OFDM is a big deal. And we'll talk about how MIMO differs between these, especially with how end in MIMO, single user, right? And we'll also talk a little bit about Wi-Fi 6 and what it brings to the table. And one of the big things particularly that you're probably seeing is OFDMA and 1024 QAM. So that's a big deal. And then we'll look at 6E as well. So Wi-Fi 6 from CommScope, first on the planet. I saw it at the Consumer Electronics Show. But here you can see what the modem looks like. It's an AX Wi-Fi 6. It offers easy mesh. That's a standard to allow better vendor interoperability. And this is so you can set up mesh networks, or users can set them up maybe with a click of an app, and very easily have quality Wi-Fi with good capacity and good coverage in their location, in their premise. This one comes with several Ethernet ports, as you can see here. It goes beyond 1 gig with 2.5 gig Ethernet port. We'll talk a little bit about these Ethernet ports and what do you need from a cabling perspective, because 5 is not going to cut it, either is 5E. So you're going to start thinking about Cat 6, but there is some other tricks up our sleeve, and we'll talk about those. And then talking about radios. What are all this 4x4, colon 3, and spatial streams? So we'll talk a little bit about that as well. Downstream data, 5 gigabits per second. So this is from CommScope. Comcast has a similar version that they have, offering a mid-split option of 85 megahertz. Also has the Easy Mesh, several radios of 4x4 dual band radios. That means 2.4 and 5 gigahertz radios, and doing 1 gig, as well as supporting IoT, which is cool. I do have some Zigbee devices in my home because I have their home security product. And you'll see this little doodad right here, and we'll talk about that. So that is an Xfinity Plume product. They partner with Plume to use artificial intelligence to improve the Wi-Fi experience. So typically what Plume is recommending is 1 pod for each room, but I would suggest to do your own investigation. There's an operator out there in Canada that has really kind of reviewed how many pods do I really need. If I have 5 rooms, I don't really need 5 pods. You could probably get away with 2 or 3. But definitely do your own legwork and test it for yourself. You don't want to add too many. And they can be a little bit costly for a customer. But this is a mesh. So here I'm providing some mesh signaling out of this outlet. Now hold on tight. Besides Plume, there's Eero that's shown here. And there's SuperPods. So SuperPods are a little bit more powerful. Every 2 rooms or so, that's what they're recommending. But again, you want to do your own testing. But a SuperPod is really an AC 3000 tri-band router. Now, tri-band is not with 6 gigahertz. It's with 2 5 gigahertz bands and a 2.4 band. It also has quad processing in it, so it does have a nice edge compute ability to it. It's really a mini AP, so it has its own compute. And it has Bluetooth radio in it as well, and a 2x2 radio. So just a little knowledge check. We're going to see anyone that can match up Z-Wave, Zigbee. I mentioned BGN. This is an older Wi-Fi standard. We really don't want customers using BGN anymore. That's B, G, or N. We really want them to be on an AC network. We want them to kind of transition their end products over to an AC, and we'll tell you why. That's going to come up. And then what's Wi-Fi 6? So if you look at the options on the right-hand side, for Z-Wave, you should have picked option 2. That's running in the ISM band, the 900 megahertz band. And Z-Wave is used for outlets. That's another alternative to Zigbee. Zigbee, you should have picked 4, but Zigbee operates in 2.4. And they operate between 1 and 6 and 6 and 11. So you have to watch that as you're picking channels. And most channels are managed now by an operator. And if you're not managing them, you might want to look at that. It's going to provide a better experience for the customer. And for the BGN, you probably pick number 1. Uses open and license-free standard 2.4. And the ANAC, 5 gigahertz. Hopefully you pick that. And for 6, you pick number 3, which is the OFDMA and the 1024 QAM I mentioned earlier. So what are the Wi-Fi bands? So here you can see unlicensed national information infrastructure is in this area, and we're gonna tell you what that is shortly. But I want to just talk about ISM. You'll see ISM is industrial, scientific, and medical band. It's used for 900 megahertz. It's used for 2.4 gigahertz, and there's a channel in the 5 gigahertz. So again, this is the entire spectrum down the bottom, and you can kind of see where these frequencies lie. And you're probably familiar with some of the RF bands, like unlicensed National Information Infrastructure 1, 2, 3, and 4, but it's growing. It's growing. So let's take a look. So here is 1 through 4. And even that's growing. You might have a device in your home that only supports maybe Uni 1 or Uni 2. And this is a limiting factor, meaning why am I not getting the throughput? Why am I not able to bond 40 megahertz channels or 80 megahertz channels? Because you don't support the entire spectrum, and they're constantly adding new spectrum. And here is Uni 4 that was just added. So this is all in the 5 gigahertz band to 6 gigahertz band. But hold on tight, because we have Uni 5 through Uni 8 coming. And this is going to be your Wi-Fi 6 and more frequencies. And Wi-Fi 6E are going to take advantage of this. So when I mentioned Wi-Fi 6, there's a Wi-Fi 6 which is not 6E. There's Wi-Fi 6 that doesn't support 6 gigahertz, and there's Wi-Fi 6E that does. Okay, but look at all this spectrum. This is 1200 megahertz of additional spectrum. Definitely want to take advantage of that. Now, again, if you're on older technology, you're not going to be able to take advantage of these things. So it's very, very important that customers understand where the technology is going and the technologies they're connecting to their network. So if we plug that in, you can see now all these channels that we have available, 5 and 6 gigahertz now, 5 and 6 gigahertz, tons of spectrum available. So this is wonderful for Wi-Fi, and we could do a lot more with a lot more spectrum. And here's a practical look at it. You can see the channel bonding on the left-hand side down here. You can bond channels 20 megahertz. Hopefully you're not running any DSSS, which are 22 megahertz channels in B. You want customers to get rid of B. All right, this is stuff that's quite old. All right, and you can see you come down to 40, 80, 160. You can bond channels. Again, if you don't have a lot of spectrum, and this I'm just looking at up to Uni 3, you're not going to have as many bonded channels. You can see down here, there's not that many bonded channels as you get wider and wider. That's why we need Uni 4, 5, 6, 7, and 8. And also be aware of DFS, dynamic frequency selection. So if you're near an airport, this allows Wi-Fi to function in areas that are reserved for radar. So sometimes if radar is being used, you're not going to be able to use those channels. So we need that extra spectrum. And this is what it looks like, a channel with, on my devices here. You can see I have the ability to use 80 megahertz channels in 5. Now, we're not going to be bonding channels in 2.4. They're just too busy. There's too much there, and I'm going to show you. But there's no reason why you can't do 40 and 80 in the 5 gigahertz band. Okay? And so that's important. And as we go into SOHO, which is small office, home office, we want those gateway routers to bond as well. Now, I'm not going to spend too much time on this, but you can kind of see all the channels. Now, we really want to make sure the devices that you're supporting support all these channels. And obviously, you might not have channel 72 to 92 because you don't have the 2B. And that might just be the device that you purchased. Okay? Now, over here, on 2C and 2E, this is what they call extended. It's all part of 2 now. You might not have 144. Okay? Channel 144 is new to 11AC. So end devices, if you put your access point on 144, now you're trying to hook up with the Xbox and you cannot connect because N doesn't know what it is. That's a tech tip for you. So always be aware of the channels and making sure the client matches the access point, kind of like impedance matching in cable. And here you look at 3 and 4, and it just kind of gives you some of the channels. So really be on the lookout for 4, and 5, 6, 7, and 8 are coming soon. And we'll talk more probably in another presentation. So how many Wi-Fi channels in Uni 3? Did anybody remember? Anybody remember? You should have said 4, and you would be correct. Okay, so that's why we need to take all these little pieces and make channels. Why do we need all those 5 gigahertz channels? We'll take a look at 2.4. You've probably seen this 100 times. But I like my little analogy down the bottom there. It's like trying to get a table at a popular restaurant in Toronto. Okay? It's congested. It's always busy. Right? Lots of congestion. We have cordless phones that act up everywhere. And then you also have cordless phones that are into 5 gigahertz. But a lot of 2.4. Microwaves are an issue. A lot of different things act up here. Baby monitors, stuff like that. Now here's what 5 gigahertz look like. Look at all that free stuff. Not as busy. You can see over here that the lower channels, the lower uni channels are quite busy. And that's just because most devices support them. Okay. But there's a lot more spectrum here. And then with 6 coming in and Uni 4 coming in, we have a lot more. So, tech tip. Not all devices support all channels. So as you're educating your customer, you need to know the models of smartphones, tablets, laptops that they're hooking up. And you need to be educated in this. If they're hooking up an Xbox and you gave them a 1 gig service, you're talking 150 megabits per second. And now they're going to have problems. They're not going to be happy with their gaming experience. Hopefully nobody has an Xbox, but just to give you an example. Let's talk RF. Now, multiplexing is a big part of how Wi-Fi becomes faster and faster and how it becomes more reliable. So DSSS, direct sequence spread spectrum, was the way it multiplexed early channels in B. And they were 22 megahertz wide. That's old. You don't want B in a network because then you have to be backward compatible with it. So you really don't want these devices at all. And the customer's got to understand that it will actually ruin the experience. OFDM is the multiplexing that we use in DOCSIS 3.1. It's orthogonal frequency division multiplexing, and that's the channels that we want. There's different types of OFDM. OFDM in N versus AC and AX, they have more subchannels, and so here you can see this is 54 subchannels. They go up to they keep increasing the number of subchannels, but the nice thing about these subchannels is we have some interference here. You can still get Wi-Fi through. And each one of these subcarriers in OFDM is a different modulation order. So I can say, oh, okay, that will be QAM 256 because there's not too much noise there. But in AX, so I'll make that 1024. Oh, well, you know what? There's a lot of noise here. Maybe I got to drop down to 64 QAM. So I'll be sending less bits per hertz. But this is the superpower of Wi-Fi, that the channel, a 20 megahertz channel, it might not be all clean. Or a 40 megahertz channel might not be all clean. And then we have OFDMA, and this is used in the upstream of DOCSIS 3.1 and DOCSIS 4.0, but this is multiplexing of subcarriers as well as time. That's why they call it orthogonal frequency division multiple access, and we have multiple users accessing the channel's bandwidth. This is cool. This comes with Wi-Fi 6, one of the reasons you want it. OFDM is great, but things get better. Now, the cool thing, which I don't have in the presentation, is that you can take subcarriers and assign them for different communication. That means you can have a light bulb use some of the subcarriers of OFDM while you have a thermostat using some of the other subcarriers. It gets really cool. More on that in a future presentation. Now, modulation methods. You should be an RF expert if you're in the cable industry. We have new to legacy across the top. Now, 4096 QAM, that would be wonderful for Wi-Fi. We're not there yet. We're getting there, but we're not there yet. We're at 1024. But as we go further to the right, that's less bits per hertz. Lower bits per hertz to higher. So here's lower to higher. So that means at 256 QAM, I can do 8 bits per symbol. Where at 1024 QAM, that symbol, you can see there's a heck of a lot more. I can do 10 bits per symbol. 10 bits per symbol. So that's more bits per hertz. That's better, right? But as we drop down, there's less bits per less and less, right? So we don't want 6 bits. We don't want 4 bits. We want 8 bits, 10 bits, 12 bits. And that's where we want DOCSIS to be at 4096 or 16384, which is 14 bits. So how many bits per symbol in 256 QAM? Do you remember? And then what is the symbol rate for an HFC running 256 QAM? This plays a role in here. So understanding RF from your HFC days are going to help you with Wi-Fi. Well, hopefully you said 8. Hopefully you were thinking 5.36 millions of symbols per second. Hopefully you calculated 8 times that and came up with 4288 megabits per second. But that's how it works. We send those symbols in that last screen at millions of these per second at so many bits per symbol. So the more bits per symbol, the better. The faster we can send them, the better. The less interference we have, the higher order modulations that we have. So even though it's working, if you can keep eliminating interference or change the channel, you can optimize it and make it work even better. Now this is what happens when you have noise. It's like throwing a dart. you want to be very precise. You want to hit a bullseye. And if you're not hitting bullseyes, you have poor QAM. In an HFC, if we don't hit bullseyes, we have poor bit error ratio. We have low modulation error ratio. This is not good. So this is why we want to be able to get the interference down, and we want to improve QAM. Another thing I want to kind of mention to you is this is high throughput. This is used for 802.11n, and this is a modulation encoding scheme chart. And this will kind of give you all the details of RF of a particular device. And first, I'll start off with the index. The index. So the index, now let me just say this. Not all indexes are supported by all N devices, but the index points, if we just take this one here, index number 3, it uses 16 QAM. It has a coding ratio of 1 out of 2, which is decent. Depending on the guard interval, it can do a data rate of 26 or 28. It must have a signal noise of 11. It must have a received strength indicator, which I'll show you of this, neg 74, and you can follow it across for 20 and a 40 channel and a spatial stream. Here is 2 spatial streams, what they look like. And a spatial stream, let's talk about that. A stream carries Wi-Fi data. RF signals are multiplexed by different spaces within the same RF channel. So, a radio chain is a group of radios, and a spatial stream is a data set sent by a transmitting radio chain. You might have to rewind this and play it again. And this all is mathematically recalculated at the receiver, which is the client. So that's what spatial streams are. That's something you want to kind of pay attention to. So the more spatial streams you have, the more bandwidth you have. The more radios you have, the better. And here we can see 4 spatial streams. So topping out, 802.11n had a 31 index, and if everything was maxed out, you could do 600 megabits per second. You find me an N device that does 600 megabits per second. Most of them only did 100 because they were cheaper, and that's what people buy. So these are important. It's called modulation encoding scheme charts. Very, very useful. Tells you the RSSI. So you're wondering, what is the RSSI? What is the signal strength? 64. You need a 64. But if you're bonding, you got to go over to a negative 61. And how about one for very high throughput? This is 802.11ac. And I didn't pull all of the spatial streams, but 3 spatial streams here. AC can do the max data rate of N at index 9 versus 31 using 256 QAM and 3 spatial streams. And its RSSI is negative 54. So which attenuates more? 2.4 or 5? You should know this one. Higher frequencies attenuate more. This is a big deal. As signals change, lower frequencies like 2.4 have longer wavelengths, so they propagate further. This is very, very important for SOHO, small office, home office, and resi locations, where higher 5 and 6, their wavelengths are shorter, and they don't propagate as far. This is one of the issues when you're doing upgrades for customers, or as customers are changing over from a 2.4 to a 5 gigahertz network. Attenuation and amplitude. The higher the amplitude, obviously the longer it can propagate. But if you have an attenuated signal like this one on the right, signal B, well then you're not going to propagate as far. So it's very, very important to remove obstacles that create attenuation. Tech tip. Every 3 dB doubles the power. So if you can improve your RSSI by 3, you can double the power. So that's 100 milliwatts doubled is now 200 milliwatts. And that's the power. That's what we use for power. And you have dBMs, decibel reference to 1 milliwatt. And that's what RSSI is measured in. Another good thing, you should know how to go between or calculate dBMs to milliwatts. 0 dBm equals 1 milliwatt. Okay, if you didn't know it. That's another lesson. Free space path loss. This is just loss in the air. This is no obstacles. This is a challenge. So the further you go, you can see you attenuate all the way over to the receiver. So just keep in mind that this is just based on free space. We also have loss based on obstructions, and you've probably seen this in the severity. So anything we can do as we do our site survey is remove these obstructions. Try to do not remove them. You can't obviously take the fish tank out of the house or take the door off the hinges, but try to talk to the customer about placing the access point in a better location. Don't just put it in the location where it's always been or where the RF outlet is, okay? So very, very important. And there's all types of RF propagations, absorption, and metal absorption. I'll show you some of that. Antennas. The antennas, if you have an access point, might have 8x8 or a 4x4. This is important. Obviously, the more antennas, the better. But remember, the clients aren't going to have an 8x8 or a 4x4. Your devices might only have 1 or 2 antennas. But keep in mind the radiation pattern of these devices is omnidirectional, like a donut. And it's 360 degrees of horizontal coverage. So the height of this, on a table or a little bit higher might be better for RF in that room. Or shoving it behind something is not so good because the donut can't expand, or putting it against a wall. Obviously, the ideal location would be right in the middle of the room. But obviously, the customer's not going to allow you to do that. But please don't do this. Just don't do this. You got one wrapped in tinfoil because we think it's going to propagate better. We got one up here, up in the window. We got one shoved in the metal pipes. Picard is like, what? No! Oh, man. So they're bad installations. So here are some terms: absorption, diffraction, reflection, refraction, and scattering, and some of the terminology. Since this is being recorded, you can go back and try this. Pause it, see if you can answer them. I'm going to kind of click through here. And absorption reduces because it absorbs it. You have diffraction. This is passing through an opening, and then the wave gets weaker. You got reflection, maybe a mirror that's in there, reflecting the signals, or glass, older glass. Refraction, the bending, think of a fish tank, or think about you standing in water and looking at your feet. And then scattering. And that could also be glass as well. So deployment. Good news. A little fun here. Good news. We won the bid to build a nationwide wireless network. Oh, sounds familiar. Bad news. We don't know how to build a nationwide wireless network. It's wireless. How hard could it be to not install wires, right? So, installation steps, some of the things we recommend. Check, perform the site survey. And do that in person if you can. If not, you need to talk to the customer like a tech support agent. Qualify the drop, making sure the drop is good. Look at the P&M tools, making sure there's no issues with the drop or the bond. Verify the premise wiring. There's no 59 wire. Install the device, gateway router, access point, cable modem. Verify. You need to verify the install. Verify the provisioning. Verify the wireless services. Connect to the internet. Do all these things and review the services and educate the customer. So, perform the site survey. Review the requirements and expectations. Now, that could be in person, or that could be as a tech support agent. You have to identify where are these coverage areas. Where do you want to use Wi-Fi? Well, I'm going to use it here in the family room. I want to use it in the bedroom. So you need to visually or work with the customer to say, okay, where do I need to put the access point? Am I going to be using pods and doing a mesh style network? Where do I put those? If you're there in person, you can look for obstacles, or you can ask the questions to the customer about what type of things are in the room. Review the existing network. Do you have an existing network? Yes, I do. I have a 2.4, or I had this network for a while from you guys, and you could look up the specs and say, okay, we're going to take them from 2.4 to 5. We need to we have to educate them on 5 gigahertz. Determine the optimal location. Don't put it in the same spot. Qualify the drop. Maybe you go to the customer's location and check the drop. You just don't enter the home. But you need to verify the wires are good. That you got to get that out of the equation for wireless. As long as the wired part is qualified, we can then focus on the Wi-Fi issues, right? This is an important step not to be skipped. Check the premise wiring. Look at this, right? Make sure the wiring of the premise is good. Do we have 59? Are we daisy chaining the connectors? What do the metrics look like with a signal level meter? I looked at the ground block, 3 points of contact, ground block, tap, and then in the home. What about Ethernet cabling? Do you have proper Ethernet cabling? Most people haven't been thinking about that. Do you have Cat 6 on the truck, right? And verifying cabling with the Ethernet tester or making sure there's a good jumper. I'd like to mention 802.3BZ, which is Ethernet that operates at 10, 5, and 2.5 gigs. This is called MGig, multi-gigabit connections. Something you should need to pay attention to. 5E is not going to cut it. It only is 1,000. And we know that Wi-Fi 6 is coming. So why not, while we're there, put in Cat 6? Or you can use NBASE-T. NBASE-T will allow you to exceed 1 gig with some magic. Okay? But if you don't want to depend on NBASE-T, then that's where I suggest doing 6 or 6A. 6A would be the best here because it goes 100 meters. And that's supposed to be meters as well, 55. So 6 and 6E do 55 meters. Do the site survey. Okay? Using all the data from your site survey that you determine, install the Wi-Fi devices. Put them in the proper location. Make sure that everything's booting up correctly. Don't take shortcuts. Don't, the outlet's over there, that's where I'm going to put it. No, you talk to the customer, you found out where they're using Wi-Fi, put the device where it belongs. Put the pods in the coverage areas where the customer wants to use the devices. Well, I'm going to use it in the bedroom, we should put a pod up in the bedroom. I'm going to be using it in my back office. I'm going to be using it in the family room. Spread out these devices. Verify these devices. Now, when you verify, you should use a test laptop similar to what the customer has. Now, don't be using these USB connectors on the laptop, and I'll tell you why, because sometimes USB version 3 outperforms internal Wi-Fi cards. So when you test it, it's phenomenal. When the customer tries it, it's terrible. Also, set expectations. With an Ethernet connection with the overhead, you're not going to get 1 gig. You're going to get about 950. You need to explain this to the customer. Well, I'm going to directly connect to the access point, so I should have 1 gig. No, there's overhead in Ethernet. Oh, my TV. I want to watch 4K. Well, your TV doesn't support 4K. Oh, it only supports HD. All right? You have an NTV. It's going to be 150 megabits per second max, which is fine for HD. But if they don't have a 4K, it's not going to magically appear. So you got to educate the customer. I have a 1x1 Samsung Galaxy. What's the model? Excuse me. Okay, you have a 1x1. That's only 433 megabits per second. You're not going to get 1 gig. You might get 866 if you had a 2x2 antenna in your Samsung Galaxy. So these are things to be aware of. Verify the SSID is operational. Make sure it's in the list. Verify the RSSI is good. Neg 65 or better. And that's going to allow for voice over Wi-Fi calls as well as data and as well as your video. Now down here somewhere is my RSSI, and I can't see it. There it is, neg 51. You're like, neg? Well, RSSI starts at 0 and goes to neg 100. Neg 100. 0 being perfect, negative 100 being the worst. So the closer to 0, the better. Negative 65 is great. Even better would be negative 55. Even better would be negative 40. But you don't want to be negative 80. So definitely use a tool to do that. This is why WinFi, free. Put it on your laptop if you're allowed. You can also use other tools like Channelizer that I have here with YSpy DBX. And then you can actually look at the channels. You can look at signatures. You can look at traffic over time and the waterfalls. This might be nice for a business customer doing a post-site survey, verifying everything works correctly. The most important step everywhere. Explain, educate to the customer. Everything I just told you. Tell them how 5 gigahertz works. Why is it different than what they had? Tell them about their legacy client devices. Tell them what they have. Tell them why they're not going to get 1 gig. Why doesn't it? You don't want them to call back and then you get a return truck roll because the tablet's not working, or you have a tech support agent spending 30 minutes displaying the type of phones that they have or the TVs that they have. You really have to think about the devices they have and the speeds, okay? Single AP, mesh AP, explain. You now have a mesh and there's different devices, making sure you don't plug this into a outlet with a wall switch. Review all the services that they purchased. Very, very important step. There's different types of APs. Single, autonomous, intelligent. There's controller-based. As you get into business services, what we call lightweight APs or thin APs. These are really fat APs because it's everything in one. And then you got the mesh or cooperative or split MAC. All right, we're going to be doing the mesh, but maybe in business services, you might do some controller-based or split MAC, where layer 2 is split between devices, the access point and the controller. You have single user MIMO. This is important because if you have old devices like N, that's 1 stream at a time. Single user. However, when you start using AC, I have 4 streams at once. So there's less contention. The only issue is only 1 stream at a time upstream, and that's via a trigger frame. But you have 4 downstream. So this is big, just by going to AC. Now watch this scenario. Tech tip. Oh, I got my N iPad 2. Why is my RSSI so low on the iPad 2, but great on my phone and great on my laptop? It's because of multi-user MIMO. N does not support it. And that's why it's picking up low RSSI. Got to educate the customer. This is an older device. This is how it's going to work. And it could be as bad as neg 80. Again, still 1 station or client in the upstream. Hold on, folks. Wi-Fi 6 is coming. 8 AP to station streams. 8 station to AP streams. All by trigger frame, OFDMA. And this is where we want to get. So this is going to be a huge, huge thing. Less contention. So thermostats, more devices can talk. And the streams could be subcarriers of OFDMA. They don't have to be the whole channel. So stay tuned for that. You have band steering. Band steering is steering devices that support 2.4 and 5 and steering them to 5. You have to support 5. So this is a big deal. And the devices that we use have band steering. We want them to be in 5 because 2.4 is too congested. We also have beamforming. So 11AC supports explicit transmit beamforming, where there's communication between the client and the AP to set up the beamforming. And then you'll get something like this in the bottom right, which I'm sending more RF energy in the direction of the client. These are all cool features. Now there's implicit transmit beamforming in N, which is not as good because there's no communication between the client and the AP. So again, another feature, and these are things you can educate the customer. You're going to have better RF, better signaling because this is a better device. It has explicit transmit beamforming. So what are the challenges? Obviously, we talked about 2.4 versus 5. Look at the interference range, but heck, look at that bandwidth. Some of the common causes of Wi-Fi failure. We're going to go into some of the detail. High number of users on a single AP. Security mismatch. DHCP not working where you're not getting your IPs. Distance from an AP. ISM band mismatch. Co-channel interference. High multipath. Standards capable of the client. Maybe the client doesn't support all the standards. It's an end client. It doesn't support AC. Power surges or firmware on AP is not working or significantly out of date. Channel bonding. Can't do it in ISM. And hidden node, where 2 clients don't even know about each other, so therefore they transmit at the same time. Intermittent no connectivity. Low signal and noise. You need 25 dB or greater. Low RSSI, neg 80. That's no good. That's be like neg 65, neg 62, neg 60, whatever your company says that they would like at an RSSI. We don't want any Wi-Fi generated CCI, co-channel, adjacent channel, or radio frequency interference. So what should the minimum RSSI value be if the noise floor is neg 88? Now you heard me just say it very quickly. What should the minimum RSSI value be if the noise floor is neg 88? Da-da-da-da-da. You should have picked neg 63. Remember I said it should be 25 dB of signal or better. So this is an important factor as well. If you got lots of noise on that channel, you can't get 25 dB of signal to noise. That's not a good channel. We need to figure out what's causing that. Now, obviously, other factors, latency. Wi-Fi is half duplex. It means you send or receive. It's not full duplex where you send and receive at the same time. Look for interference, especially in MDUs. That's multiple dwelling units. These are apartment complexes. See if you can figure out if there's other interferers there. Non-Wi-Fi, security cameras, baby monitors. Distance from AP. You're too far away in the basic service set coverage area. Materials. You're trying to go through metal studs that are behind sheetrock. Misconfigured security settings. How many times have you had that problem? So Wi-Fi 6. Drivers for Wi-Fi 6. DOCSIS 3.1 obviously is going to give you 1 gig, so we need more. Obviously, we want to go to 2 and 2.5 and maybe 3 and 5 gig services over 3.1, and DOCSIS 4.0 is coming. Obviously, you might be doing some EPON or GPON or even XGS-PON at 10 gigabits per second. So passive optical networks. People want to do 8K, high dynamic range, and virtual reality and gaming. More IoT devices. Trust me, we'll figure out a way to keep the bandwidth curve going. Tail of the tape. AC versus AX. We kind of talked about it. AX is built with 2.4 and 5 in the spec. AC was just 5, and then they added 2.4. The channels look pretty much the same. The FFT size, which is the number of sine waves, not all subcarriers are occupied, but you can see there's more sine waves, and that means I can send more bits per hertz. AX, subcarrier spacing, much smaller. So that means more bits per hertz. The symbol duration is much longer, so less interference. Higher modulation order, I told you that one. The use of orthogonal frequency division multiple access, where I could take subcarriers and assign them to conversations. That's a big deal. And you're looking at just 160 megahertz, 8 spatial streams, almost 10 gig. So all cool stuff. It's a 4 times increase. Subcarrier spacing, here's the spacing of 5, here's the spacing of 6. We also have Wi-Fi hotspot benefits, so obviously Wi-Fi 6, outdoor performance, longer cyclic prefix, so meaning longer symbol durations, less interference. New packet format, so it's more robust. Let's see what else here. Yeah, microflections in the channel are reduced. Less delay, less latency. So all designed for outdoor benefits. So those Wi-Fi hotspots, we can bring them up to Wi-Fi 6 as this technology matures. You have target wake time. How about we save a little energy? Power save. That's what this is about. This is Wi-Fi 6. Target wake time. Enables devices to determine when and how frequently they will wake. And actually, we could send trigger messages, and then they wake up from their sleep and start communicating. So that's a nice feature. Less battery. So devices that use batteries, like home security, I can extend that battery life. I talked about Easy Mesh already. So Easy Mesh is here. That's part of 11S, IEEE 11S. So global spending here on these networks was 5.3 billion in 2016. It's going to double. Well, a little bit more than double, 11.1 billion by 2025. So more and more mesh. We know this. You're doing it. Another thing is coming. WPA 3, WPA 2 has been is good, but with all the compute power that people have, more and more of these protocols, WPA 2 AES, can be compromised. TKIP that was part of WPA 2 was already compromised, so we can't use that. So they added more bits of encryption for enterprise. So that's a big deal. More security. Stay away from Wi-Fi protected setup WPS. It's no good. So stop using it and educate the customer. 6E, something short here. We talked about it. It's really about the 6 gigahertz band. You'll see 6 capital E for that. AR, VR, more. Okay. 1200 megahertz. This was announced by Chairman Pai in September 2019. So 14 additional 80 megahertz channels, 7 additional 160. Excellent. A little bit of troubleshooting. Wi-Fi metrics. Signal, let's start off. Perfect RSSI. I mentioned receive signal strength indicator. That would be 0. The minimum would be -100. Your noise floor typically is down there, -95, -90. You can see an adjacent channel interference that's there. You can see your channel. This is all under 2.4. You can see the power of my channel. That's my signal strength, -62, or my RSSI. My noise floor is -95. I calculate my signal and noise, which is acceptable, 33. And we talked about good RSSI. Again, this goes from 0 to 100. So plenty of tools. Here's a tool, WinFi, that I use, and you can see that mine here was, I can't really see it, but I think it's like -50, -65 or better, and you could do voice over wireless LAN calling. My network's called GG. Sorry, it's -49. Okay. There's other tools. Wi-Fi Analyzer lets you look at RSSI as well. And MSOs have their own tools. So you can use the MSO tools. You should be using all the same tool. Obviously, low signal noise is an issue. That means it's less than 25. You're going to start having issues. There are tools to look at signal and noise. So this is WinFi. Cool. I can look at signal and noise. Right over there. Not there. Mine was -45. Okay. And dB, not dBm. Okay. It's a ratio. You can look at the spectrum. This is Insider, another tool. I can look at 2.4 or 2.5 or 5.5 gigahertz, which I'm looking at. Here's 2.4. Wow. And here's another shot of 2.4 with Wi-Fi Analyzer. Now, we talked about some of the issues, high number of users, devices on a single AP. I think we don't have that issue within a residential home. You might, but think of more of businesses. Security mismatches, unknown passwords, and maybe DHCP networking. We should put everybody, as far as security goes, on WPA2. Distance from AP we talked about. The further away you get, the less amplitude. We talked about that. And ISM band is a 2.4. It is congested, so there's not that many channels. So really using 5 is much better. And there's too much co-channel interference in ISM. And a lot of multipath. And then that comes to high multipath. Reduces throughput as well. Standards capability of the client. Definitely making sure the client matches the AP as best as possible. If not, educate the customer. And the hidden node issue. This is where two clients can't see each other. So all things you need to troubleshoot. Here's hidden node. Client A and B can't see each other. It's contention based. So it's clear to set. It's CSMA, CA, clear to set, carrier sense, media access with collision avoidance. So they both look at the carrier and say, oh, it's free. I want to transmit to the AP. They both transmit because they don't see each other. And boom, we have a collision. So there no one's transmitting. So try to avoid that in your Wi-Fi setup. Intermittent no connectivity, password. Security is always an issue. DHCP, verify that you have a public IP. This here is a private IPv6. It's an FE80. It's link local. I'm not going on the internet with that. I'll show you next slide what it looks like to go on the internet. So verify you have an IP address. You don't have a PIPA 169. I have a 192. That looks okay. For IPv6, I want a 2 address. A 2 address. So I should be able to go out there. My authentication is here. And this is some metrics with Wi-Fi Analyzer. The further you get away from the access point, the worse the signal to noise. The less amplitude of the signal that you have, the less QAM that you're going to be able to use on your OFDM channels. Performance management, benchmarking. It is recommended as a cable operator that you benchmark your own devices. Many of us use different vendors. It's important that you test your vendor's devices and different client devices so you can educate the customer properly. They need to understand the devices they're trying to put on the network and the capabilities. And stop blaming us. It's not my fault that you have an Xbox that's 802.11n and only runs at 150 megabits per second and you bought a 1 gig service. You're never going to get a 1 gig. Or that TV that doesn't do 4K. So this is an example of a tool that you could use to benchmark the devices. And here is a little video playing here. Let's see if I can get that to play. And you can kind of see this is a video of 2.4, an analyzer that you can use. And you can see a lot of activity here at channel 1. And then down below, it gives you all different signatures. So you can actually match these up and figure out what are the interferers. So it's pretty cool stuff here. And here's one at 5 gigahertz. Here you can see some of the interferers, which are some out-of-band signals that are causing some interference. USB noise from external hard disk or memory stick. Yes, in 2.4. Another reason not to use 2.4. There's a whole white paper on it. Band steering concerns. You have persistent clients will not move to the 5 gigahertz band. Therefore, they will not have internet connectivity. So you have it enabled. Some folks are disabling it. You want band steering. You want devices that support 2.4 and 5 to move to 5, where it's a much better space to operate. So definitely look into why the probe requests are being ignored. Maybe you can set up on your AP to define a number of ignored probe requests before allowing a 2.4 to stay in 2.4. Also check these values on the client that they're not set and forcing it to go to 2.4 and not prefer 5. So that's my presentation. I hope you enjoyed it. So I really encourage you to check out some of the stuff that I presented to you. Wi-Fi must improve for our customers, as we talked here. And how do we do that? We educate ourselves. We follow recommended and best practices. And educate the customer. Educate the customer. Educate the customer, right? Know the standards. Know how to educate the customer. Hey, this TV supports this. This gaming console supports this. This mobile device, this is what this supports. You should be able to explain common ways to troubleshoot Wi-Fi, band steering, for instance, or MIMO issues. Leverage our best practice. It's free. Go to our website right now. Go download it. Or email me. Invest in your workforce or invest in yourself. Get an SET membership. We have tons of resources here. Grab yourself a broadband wireless certification. So I mentioned SETE 255. Grab yourself a BWS certification or even grab yourself a class. Our class is actually, as an authorized learning center for certified wireless network professional, will allow you to pass these two as well. Or sign your organization up for a certified wireless network administrator boot camp. Get some experts in Wi-Fi that can troubleshoot those high-profile customers. Thank you. Appreciate it. I hope you enjoyed the presentation. And here is my email. If there's anything that you need, please reach out. And thank you very much for your time.